Hi everyone, so today we're going to explore negative exponents and how to rewrite expressions with positive exponents only. So let's take a look. So before we really get into the rules of negative exponents, I want to explain why that rule exists and why it makes sense. So say we have something like x to the fifth over x to the third. So there's two ways to do this. The first way I'm going to show you is to expand both of these and cancel out. So for example, x to the fifth is the same as saying x times x times x times x times x, 5 times, right? And then the same thing with the denominator x to the third is x times x times x. Now we know that we're able to cancel some of these out. We can cancel out this pair, and this pair, because anything divided by itself is just 1. So we're left with 2 x's, which is equal to x squared. Now, if you remember the subtraction rule here, say I wanted to do this a little bit faster. Our rule is if we have the same variable base, or just the same base in general, we're able to subtract our exponents. 5 minus 3 is going to give us 2. And we can see here that these are the same, right? So we know that this is definitely equal to x squared, either by the expansion method or by the subtraction method. So now let's take a look at another example. Say we have x to the third over x to the fifth. We can do the same thing. I'm going to expand it first so we can look at it a little bit like this. So we have 3 x's in the numerator and then 5 x's in the denominator. And we're going to do the same thing. We're going to cancel some stuff out. Anything divided by itself is just 1. So these 3 cancel. And you're going to see that we're left with 2 x's in the denominator here. So how we would write that answer is we still have a 1 in the numerator, because remember, anything divided by itself is 1. So it's not like these just disappear. They're actually equal to 1. So we have 1 over x squared. Now let's do the same problem. Let's do that subtraction like we did in the first example. X to the third over x to the fifth. Say we wanted to subtract these. Now we have a smaller subtracting a larger. So 3 minus 5 actually gives us negative 2. So I want you to take a look at the answer we got here and the answer we got here. So these are actually equal to each other. 1 over x squared is the same as x to the negative 2. So we're going to explore that rule a little bit in the next slide. So the negative exponent rule is this says that negative exponents in the numerator get moved to the denominator and become positive exponents. So just like we did here, negative exponent, it gets moved to the denominator and becomes positive. And that works the other way around. So negative exponents in the denominator get moved to the numerator and become positive exponents. So just like, okay, and when we're simplifying these expressions, you're only going to move the variables that have negative exponents. Positive exponents and coefficients stay where they are unless there's negative exponents involved. And we're going to take a look at that when we do some examples. So So we see here x to the negative n is equal to 1 over x to the positive n. So like we said here, negative exponents in the numerator, because technically we know that there's a little under, this is technically over 1. What we did is we take this and we move it to the denominator and we make that exponent positive. That's a shortcut here. Same thing as if the exponent is in the denominator. We're going to take this, we're going to move it up, and our exponent becomes positive. So a way to remember this is when you cross the line, change the sign. So we're crossing the line of the fraction and we're changing the sign of the exponent. Same thing here, we're crossing the line of the fraction, we're making that exponent positive, we're changing the sign of the exponent. So let's do a couple examples. So the application, we want to transform each expression into an equivalent expression with only positive exponents. So here we have we have 4 to the negative third power. So like I said before, whenever you have anything that doesn't have a denominator, it's always a denominator of 1. So what I like to do is circle whatever has a negative exponent, and I know that that's going to move down, and I'm going to cross the line, change the sign. So this becomes 1 over 4 to the positive 3. Now 4 is an integer. It's a number that we know that we can simplify. So 4 to the third power is 4 times 4 times 4, which is actually going to give us 64. So if you have an integer base, you have to simplify. So if this, for example, if this was like an x, if that 4 was an x, then we wouldn't be able to simplify it. You would leave it as is, but because that is an integer, we're able to simplify it. Okay, let's take a look at another example. We have 10 to the negative 1 power. So same thing, we're going to circle our negative exponent. I'm going to just put that invisible under 1, and I'm going to cross that line, change the sign. So this becomes 1 over 10 to the first power. Same thing, that's an integer base, so we're going to simplify it. And anything to the first power is just itself. So 10 to the first power is just 10. So it becomes 1 over 10. Okay, let's take a look at one more over here. Now we have 1 over 2 to the negative 5th power. I'm going to circle my term with the negative exponent, and I want to bring this up now because it's in the denominator. So now this becomes, cross the line, change the sign, 2 to the 5th power, because I made that a positive exponent, over 1, which we don't really need to put that over 1, but we do need to simplify this integer base to an exponent. 2 to the 5th power is 2 times itself 5 times, which gives us 32. Okay, so you can see that if it's in the numerator, we're bringing it down into the denominator, and if it's in the denominator, we're bringing it up, and we have to simplify any terms that have integer bases. So now let's take a look where we have some variables included. So we want to transform each expression into an equivalent expression with positive exponents only. Okay, so you can see that we have some variables with negative exponents here. So I'm going to only circle the variables with the negative exponents. Okay, so you can see I did not circle the 5 because it doesn't have a negative exponent, and I did not circle the c because also that does not have negative exponent. Only circle whatever has a negative exponent. I'm going to put this whole thing over 1, and I'm going to just move the ones with negative exponents into the denominator, and then keep everything else the same. If it doesn't have negative exponent, don't touch it, don't move it. So this becomes 5c, because that stays in the numerator, over, and we're going to cross the line, change the sign, a to the positive 3rd power, b to the positive 2nd power. Now we can't simplify from there. We have no same bases, so that is our answer. 5c over a to the 3rd b squared. Only move the negative exponents. Okay, let's take a look at example E. Now we have a fraction involved here. We have some same bases. So where I'm going to start is I'm going to circle my negative exponents. Remember, only circle the ones with negative exponents. Don't circle the numbers and everything like that. I know that that's going to come down into the denominator, and this is going to move up into the numerator. So I'm going to do that first, and then I'm going to reevaluate if I can do anything else. So this 4 stayed in the numerator. This y to the 3rd stayed in the numerator. And then we know that this z to the negative 6 is going to move up. We're going to cross the line, change the sign. So that's going to become z to the 6th positive. So that's a positive 6. Now in the denominator, that y squared stayed. And we're moving this x to the negative 2. That's going to come down. We're going to cross the line, change the sign. That becomes x to the positive 2 power. Now, I want to reevaluate. Is there anything else that I can do and simplify here? And if you notice, we do have 2 of the same base. So we're going to apply that rule that we reviewed in the beginning, where we're going to subtract our exponents here. 3 minus 2 is going to give us 1. So this is going to become 4 y to the 1st power, but I don't really need to write that 1st power, so I'm not going to. So let me just erase that real quick. If you want to write it, you can, but it's not necessary. Z to the 6 stays the same. Now this, because we subtracted those exponents, we don't have this y in the denominator anymore. So then the only thing left in the denominator is this x squared. Now from there, we're not able to simplify anything else. We don't have any negative exponents, so we know that we're done. So the moral of this lesson is whatever has a negative exponent, cross the line, change the sign.